Hello everybody, and welcome back to the Poor Man's Chemist. In this video, I will be demonstrating the synthesis of diiodomethane from dichloromethane using the Finkelstein reaction, or Finkelstein. I'm not exactly sure how it's pronounced. He was German, so maybe one of my Deutsch viewers can school us on how you actually say his name. I imagine it's like Einstein, Finkelstein. I don't know. Anywho, this reaction is an SN2 reaction, so it is a bimolecular nucleophilic substitution reaction. The order of reactivity is about what you would expect for an SN2 reaction. Methyl groups are amongst the most reactive, so using this reaction to make diiodomethane, it's particularly well suited for that. Primary alkyl halides are also reactive. Secondary, not so much, and tertiary and neopentyl halides are completely unreactive. The reaction can convert either alkyl chlorides or alkyl bromides into alkyl iodides, and the reason that it works is because the reaction is carried out in acetone. It is a marvelous demonstration of Le Chatelier's principle. Sodium iodide is soluble in acetone, but sodium bromide and sodium chloride are not. So as they are produced, as the reaction goes, they drop out of solution, they precipitate, which removes them from the system as a solid crystal. So because you are removing a product, the reaction gets dragged to the right. So I thought it was exceptionally cool. This was developed by Hans Finkelstein back in the early 1900s. If I recall correctly, it might have been like his doctoral work, actually, or it was part of it, I'm not sure. His father, Berthold Finkelstein, was also a famous chemist. Now, Hans is a bit of a tragic figure, actually. When I was doing some research into Hans, I found out that he died in December 1938 in Leipzig, Germany, under tragic circumstances. That is all I can find out. I also cannot find a picture of this guy. I can find a picture of Berthold, but I cannot find a picture of Hans. If you Google him, that's not Hans Finkelstein. I don't know, that's a bunch of other German chemists, but that's not him. He died in Leipzig, and when I did some research as to what was going on in Leipzig, Germany in 1938, although I had a pretty good idea what it was going to be, to the best of my knowledge, I was correct. It had something to do with the Holocaust. In November, the month before he died, so it would have been just like weeks, because he died in early December, if I recall correctly, the deportation of Jews began out of Leipzig. And, just a few weeks later, Hans is dead under tragic circumstances. So, and it doesn't, you don't have to go very far to draw the obvious conclusion here. So that's exceedingly fucked up, and that after working on this reaction and thinking about it, and like I said, the first time I tried it was a couple years ago, and this time I did it, and I actually pulled it off, and given how utterly fucking useful it is, right? I mean, hello. I mean, alkyl iodides are just endless awesomeness. It kind of hit me in the feels a little bit, man. It's very, very fucked up. I tell you what, genocide is never good. If I need to tell you that, you're way beyond anything I can do to help you. So anyway, yeah, this reaction worked. The video is a little long because the reaction is a little long. It took me almost a week to do this around my work schedule and everything. Was starting the new job, even though it's going great and I'm having a marvelous time doing it, it is exceedingly time consuming. Oh my fucking god, it is time consuming. So that's like become my life now, especially considering I didn't quit the other job, so I'm doing both of those, and yeah, it's great. It's more amenable now, I guess, to these longer experiments that take days, since I kind of need something I can spread out over days, so anywho, that doesn't mean that I'm going to be stopping the inorganic, chem completely. In fact, I have been looking at tungsten and trying to find something I can do that isn't tungstate. That'd be nice, you know. Or if it is tungstate, something much more exotic, you know, something that hasn't been done on YouTube so far as I can find. Although, you know, some other tungsten compounds would be cool. And like dissolving the metal. That would be a cool demo, because, you know, you can't do it in a normal mix of acids that you're, you know, it's not your run-of-the-mill stuff. So, I've done it before, it works, you know, it's not that difficult, but anywho. I'll save that for then. So, like I said, this video is going to be a little long, so I'll shut the fuck up and we will get into the Finkelstein reaction. So great, so cool. Okay, everybody, so here is our basic setup. I'm going to have to do this in the shed because it's going to take a while. I'm not sure how long it's going to take, though. Methyl groups are generally amongst the most active compounds for SN2 mechanisms. So, it may not take too long, but I think it's going to at least take a day, being gently refluxed. And to ensure that the reflux is gentle, what I've done here is I have hooked my little hot plate, stir plate thingamabobber up to the voltage regulator that I usually use for my heating mantle. I'm going to use that. I've already experimented with it, and at least with the flask is empty, the stir bar will still turn, so that's a nice bonus. It's not absolutely required. The stir bar will act as a boiling stone, so I mean, it shouldn't, but I don't want it getting too hot either. And this thing, when there's no wind, as there obviously won't be in here, it can easily boil water, so that's, you know, that's just too hot. I don't want it getting too hot. So anyway, I want to try to be very careful with this because it takes a lot of chemicals to do this, and I'll show you what I mean. So here we've got our dried acetone, dichloromethane, and sodium iodide. These have been dried over magnesium sulfate. You can see there is plenty in there. We do not have any kind of clumpification going on. Well, we do, but it's at the bottom. So the solvents are dry. Here, the sodium iodide, I dried this shit out in the desiccator over freshly charged 3 angstrom molecular sieves for several days. This stuff is as dry as it's going to get. It doesn't... I think that in order for the reaction to proceed as efficiently as possible, it does need to be as dry as possible. Alright, everybody, here goes nothing, man. This is either going to work or it won't. I am not sure if it's a good idea to just kind of throw everything together and hope for the best or not. So that's what we're going to do. Put your ass in there, bitches. Alright. Dichloromethane. Okay, cool. Now, all we've got to do is go ahead and set this bitch up for reflux, and we're good. Alright, everyone, we are rocking. Had a minor accident where the hose pulled out of the top of the condenser. It just, I don't know, it slipped off, but it is zip tied on there now, so hopefully we won't have any further issues because I really don't need this shit getting soaking wet. It would be really expensive to replace that voltage regulator. Anywho, so the reaction is going now. Give you guys a closer look here. There really isn't much to see. I have got it on full power right now just to try to dissolve as much of the sodium iodide as possible. The heat is on. Once it's dissolved and everything is refluxing and everything is happy, I will use the voltage regulator over here to turn down the power a little bit so that it doesn't heat it quite so strongly. And I don't think it'll have any issue stirring once all of the sodium iodide is dissolved. So that's basically it now. Now we just need to wait and see what happens. So when there is a change of some kind or something to report, I will come back. Okay, everybody. Well, the Finkelstein reaction has been Finkelsteining for probably about roughly 17, 18 hours. Let's take a look at it. You can see that we have a whole lot more white solid in there than we started with. So that is fantastic. Of course, you know, there's no way to know just by looking at it if it's done or not. But thanks to somebody on Discord, and I'm probably going to mispronounce his username there, but Naragen? I don't know, dude, correct me in the comments. But anyway, he managed to find an actual synthesis protocol to make this very product the way that we're doing it. I was very encouraged to see that my prep method was not terribly far off. So anyway, in that method, it went for about 20 hours before they stopped the reflux. So that's what I'm going to do. I'm going to let it keep going here for another few hours, and then I will shut it down. Then it's going to get real interesting because the weekend is about here, which means that my work schedule is going to be crazy, and I have to do the workup with this. I need to distill some ether still, so I've got to get busy with that. So this may end up sitting here after we're done with it for a little bit until I can get everything else in order, and I really hope that doesn't fuck my product up, because that thing is like diiodomethane. I mean, my guess is that it's going to be like a whore that's high on MDMA and crack for SN2 reactions. So, yeah, I don't know how wise it is to let it stay mixed with other stuff for any appreciable length of time. So anyway, but that's where we're at now. Again, the fact that we've got so much white solid that's dropped out is extremely encouraging. That is exactly what we want to see. That is our insoluble sodium chloride. So, and there is excess sodium iodide in there, but I'm not stressing about that, because once this is all done, I will recover all of the salt out of this, and then I will just convert all the iodide to iodine and, you know, filter it all off, dry it out by melting it under concentrated sulfuric acid, and then it will have been recycled. So, anyway, I will come back when there is something to report. Okay, everyone, here we go. This is our reaction mixture. Let me zoom you in here a little bit. It has sat here the entire day. I actually got caught up doing work a lot longer than I would have liked. But, I mean, it sat here in the dark. I left the condenser running all day so nothing could evaporate away. And it looks like it's very tame. So the next step is to filter off all of the precipitate here. Rinse that with some acetone, combine that with our filtrate, and then we are going to distill off the acetone. That will give us our crude diiodomethane, and from there it is just a question of working it up. I'm going to need to make some ether here at some point, since I never did have a chance to do that today. I'll probably get up super early in the morning and do it, since it's best to do it when it's cool outside. So yeah, I will probably do that. I will come back then tomorrow morning when I am ready to filter this puppy. I'm just going to leave it together here until I'm ready to deal with it. But I still wanted to show you guys what it looked like when it was all done. So anyway, that's what it should look like if you're not repeating this experiment. So anyway, I will come back in the morning when we are ready to move on. Alright, everyone, it is the next day, and I'm about to go ahead and filter this to get off the all the salts, the sodium chloride, and excess sodium iodide. According to Wikipedia, diiodomethane does not like light. Generally, when that's the case, you know, it likes the sun even less. So everything is wrapped up in aluminum foil here, but you already saw it, so you know what it looks like. I am going to go ahead and filter it. And when I am done with that, we are going to distill off the acetone. Anyway, I will come back when I'm ready to do that. Okay, everybody, so I distilled off quite a bit of the acetone earlier today, and then I had to go to work and let this sit here for a little bit, but you can see what we've got here. The yellow color is from iodine, I think. Pretty sure that's where it's coming from. You can see we've got a whole bunch more alkali halide, which is probably sodium iodide, given the excess of it that we used and how it appears to have dropped out of solution as the acetone was evaporated off. Wash it out here. Okay. There we go. Oh. Alright, so now what I'm going to do is I am going to continue to evaporate off the rest of the acetone, or at least the vast majority of it, and then we are going to clean up this iodine in here, get that out of there, and then we will do the final distillation to get our purified product. So I will come back once I have gotten rid of more of the acetone and I am ready to move on to the next step. Alright, everybody, so almost all of the acetone has been distilled off. You can see we've got a little bit here, and more, almost certainly sodium iodide has crystallized out. I am going to stop here though and go with this at this point. Yeah, we are just going to run with it. So, alright, got that done. Now the next step is to add water to this. I have not found anything that says how much, so we are just going to kind of do this as good as we can. Oh, look at that, little droplets of orange stuff. Oh, that's pretty cool. What do we got down here? Oh, yes, there is orange stuff on the bottom. Alright. I hope that's a good sign. No, and it's even liquid, little droplets of orange liquid. How very cool. Alright, so we've got our water in there now. What we need to do is transfer this over to a separatory funnel, although I think I'm going to get a bigger one just to be on the safe side. Okay. Let's get this all set up here. Maybe not. Go. Now we need to make sure that this is closed. Yep. Alright. And now I am going to transfer everything into the separatory funnel. Oh, closed all the way. Okay, good. Yeah. Alright. I don't want it dumping out of there when I pour it in here. Aw, fucking stir bar, damn it. That was real smart. Alright. Alright. think we got it there. Since this stuff is essentially liquid cancer, don't get it on your hands like I just did. Okay, so you can see that's our product, and you can see we've got little droplets of it. Cool. The next step is to dissolve our product in some ether. I have just under 100 mils here that I've distilled out. And while you should always extract into multiple batches, well, we might have enough to do 2 of them. Maybe. Yeah, maybe not. Oh well. First time I've ever done this, so, you know, the yield might not be stellar. And that's okay. It's a learning experience. Alright, so now we're going to do the usual deal here. Let me move you guys back so y'all can see this shit. Alright, so we're going to invert and swirl. And our diiodomethane will dissolve into the ether layer. And I really, really hope that that's enough ether. What is that orange shit down there? Okay, I do not know. Although, interestingly, the first time I ever did this reaction, I got that same orange shit. Yeah, fucking wind. Well, that's curious. I don't want to create an emulsion. That is the last thing I want to do. Okay, there we go. Yay, we got it. Alright. Give it one more little swirl just to make sure we got it all. Alright, now I'm going to let this sit here for just a minute so that everything can separate out completely. And I will come back when that is done. Alright, now the next step is to wash this with some aqueous sodium bisulfite in order to remove the iodine that is dissolved into the ether. I'm being lazy and using the ether jar. Alright. After all, it's not going to matter. Wow, look at that go. Damn. I guess it does remove it. In pretty short order. Alright, let's give it some swirlies here. Did that shit not all dissolve? Are you kidding me? That is simply unacceptable. Don't worry, we're going to dry the product too here in a little bit. Hello, come on. Get your chunky ass down in there. You guys see this? I don't even know if you can fucking see this. Look at that. We did pretty good removing the iodine. Alright. Now, the presence of iodine is not going to harm what I want this for, so I'm not going to stress over it too much. Okay. Alright, let that separate here for just a second. Alright, now we need to draw off the water layer. Once the ether layer is dried, we can evaporate this, and then once the ether has been evaporated, it says to fractionate our product under reduced pressure. There will be some chloroiodomethane that will come off first, and then we will be left, it should just be pure diiodomethane. Okay, go ahead and remove our water layer here, along with that bit of whatever the fuck that is there. Alright, so I have a dry round bottom here with some dry anhydrous magnesium sulfate. And there we go. Keep it capped so it... Excellent. Well, you can see how wet it was. A lot of that stuff clumped right up. But, as you can see, if I hold it up high enough, it's not all clumped. We do have some loose, still powdery magnesium sulfate suspended in the ether. So that means that we have added enough. It is dry, and I'm just going to let it sit over this for a little bit, and then I will filter it out, and yeah, then evaporate off the ether, and we will have our pure diiodomethane. Okay, people, it is done, or at least as done as it's going to get. I'll show you here real quick what it looks like. You can see it has turned a little bit purple because of the sunlight, but I mean, if there is a little bit of iodine in there, I don't really care. It's not going to hurt it for what I want to use it for. So I just want to get it out of the light though. But I mean, I want you guys to be able to see it too. Look at that. That is so fucking great, man. It fucking worked. It actually fucking worked. The first time I tried this shit, it crashed and burned so hard. Oh my god, this is so fucking excellent. I would demonstrate it actually freezing because it freezes between 5 and 6 degrees C, but I had to use a little bit of just straight starter fluid to rinse out the solution off of the magnesium sulfate. So there's going to be a little bit of heptane in here. That is unfortunately unavoidable, but again, heptane is not going to really cause a problem for making samarium diiodide. It is already as reduced as it can possibly get and should be pretty inert. So I don't think that's going to cause a problem. So anyway, so yeah, there we go. Look at that, people. It fucking worked. It fucking worked. That's so fucking great. I'm so glad too, because my god, this one took a long time. So anyway, if you like that one, y'all, give it a thumbs up. If you didn't like it, well then I really don't know what it fucking takes to please you. Subscribe, comment, share the video far and wide. Show people the wondrousness of being able to make alkyl iodides from alkyl bromides and alkyl chlorides easily in your backyard. Oh, that's so great. Until the next one, y'all, I will see you later. Oh, that is so fucking awesome.